Alrighty. Figured I'd start streaming while I work on this because somebody out there might want to hang out or be entertained by my efforts. I'm going to go ahead and pop myself into developing as well. So if anyone wants to come talk, you join my Discord, you can just join developing. Anywho, yeah, so what I'm adding or attempting to add is I have a project called EQX, and I'm actually adding a GLTF loader. So in theory, I just made it. We're going to open up Blender, make this box, which is your classic, and we're going to actually export it as a GLTF. Start with GLTF, and we're going to just go to my directory. Actually, one more, EQX, build, bin. We're in the debug mode right now, and we're just going to call this box.gltf. And we're going to go ahead and also export a GLB. Like so. Cool. Now, I added this function called GLTF to world, and we need to see if this actually works. It's going to be loading it into model. What does model have on it? Oh, we got lots of stuff. Let's do vertices. Let's buffer views, buffers. I actually don't know this extension very well. Meshes might be. Thank you. I don't know if this is C-string compatible. Nope. Now it is. Okay. Let's plug in GLTF to world in my little extension parser up here. Here we go. GLTF to world. Okay. Let's compile it. Oh, unresolved external symbols to load image data. Interesting. Why? Am I not linking it properly? Is that what this is? So in my common, I have headers, and in headers, I have GLTF, right? There's no CPP files from what I could tell. And tiny, what references like STV image? Something else uses STV image, but you can see it's here. Hashtag includes STV image isn't STV image, which is a little weird. GLTF includes it right here. That's just really far down. What is STV image even doing? Just an image loader? I mean, does this need to be GLTF? Is that what this is complaining about? Let's try it. Don't know if that's right, but Wait. Load image data. I don't know if that's the same error. Let's try it. Nope, it's still not happy. Pretty sure it's importing right. Load ASCII from file. It's not being linked properly. But it's being linked in here. I include the common directories. And I do common here for target linking. But it's telling me that I might need to move this chat up a little bit. It's kind of in the way of my stuff. Okay, so why am I having a link issue now? Let's see. Yes, we reference load ASCII from file, and it's saying it's not found. Is my tiny GLTF including properly? Yeah. Maybe I need to include some of these other paths, like S2B image. Let's try it. Because we got about 6 errors right now. And then we still have 6 errors. Okay, so this was telling me all I needed is tiny GLTF right here. But it's saying we can use the add subdirectory feature, which is doing it right here. I don't know if these options really need to happen, but we can go ahead and build it. Yeah, it doesn't seem to have impacted anything. I mean, I could try. I shouldn't need to do this, but that rebuilt everything, adding in that import. It's probably going to error something new, but we'll see. Nope, that changed nothing. I didn't think so. Normally an include will do recursive. It has to because my Quake 3 folder is also a subdirectory, and I don't ever specify it, and it still works fine. It just has to do with the fact that common is loaded here, and then in common, we have the different headers being included. So we're having a library reference issue. An external symbol is unresolved. Let's try doing a clean. Isn't there a way to like change? I mean, the easiest way is we go to the build folder and we just delete the CMake cache. And then we can set this and now we're regenerating the CMake file. Okay, let's build again. And same error. 7 unresolved symbols, and they're all symbols that have been baked using my new import. What would also need to be included? Let's look at this real quick. So, in my common CMake list, I have my Quake 3s as CPPs, and I also have my Quake 3s as headers. And then my GLTFs are right here. So that looks perfectly fine. Then you have the Quake 3 includes, and then you have the imports here. This isn't normally too difficult. Why would I? Let's double check that it's including the header file. It might be because there's no CPP, it's having a headache. We could also try this just temporarily. I'm going to try to put these header files into my source directory. And then we're going to go ahead and put it in the CMakes. Like so. Where is the other CMake, by the way? There we are. Let's take that, toss it in here. There might be a conflict because I'm including the same file twice. Yep. Well, that's interesting. It says it can't find a source file, though. But regardless, we're now going to go back to the old header file and temporarily take these out. With the hope... Okay, wait. Cannot find... Oh, that's right. I am including with a... There. So we're still getting an external symbol error when we have it inline on the actual project. Huh. That's wonky. I need to think about this. Why exactly would this not import correctly? Double checking the README. We can go look at some other projects that use this real quick and look at their CMakes, because they're going to likely have a similar setup. Of course, I'm not fully sure where they're going to have these files. Wasn't it like control? No. T? Yeah, you can type T, and then you can start filtering and find files like tiny GLTF. No? This might not have, like this sample might not have what we want. Let's try like a quick look GTLF and see if it has, there. They call it tiny GTLF scene, but okay, so they're actually importing the entire project. By the way, that's actually really cool. It lets you do it actually right into OS X. I might take that later. That's a good one. But that alone... trying to figure out here. None of these projects are super simple ones for me to just look at and get these imports. This one actually looks good. External, tiny GLTF, boom, there's the 4 files, right? And this is importing just the directory. And the directory does not have CMake. So it's actually importing it a little different. I mean, arguably this would do it. Perhaps I don't need to put it on this. Let's try that actually. Let's take these directories or files, put them into common again. They're still there. Okay. So we can just delete these files now. Run a build again. And this potentially will... No such file. Oh yeah, that's right. EQX needs a GLTF prefix. And I likely don't need this. Guess I could look at their issues. No, this is all. Yeah, I mean, we could double check their examples here. Like here's a GL view. And it is including tiny GLTF. And it actually isn't doing the namespace include either. I wonder if there's like a name conflict. Let's try something like this real quick. We're going to comment out all of the code just to see if it'll compile. Yes. Okay, so what if I put just the header variables? Does this cause an error? Yes. So the tiny GTLF isn't being linked properly. Do you think this doesn't feel right, but yeah, there's no library being included there. What is the yeah, see, there's only libraries being made for common and log. Interesting. Why am I having so many issues? Let's replace that. Let this rebuild. I'm curious if the common lib is including, what is it called? Like PDV browser debug. There's like some tools for this. PDV Explorer? No. Is CV dump? I don't know if I have this. all I'm doing is I want to verify if the linking is actually doing it, because if it is linking, we know that it's an issue with how we are running our imports. I kind of want to keep this handy because I've been using this quite often. It doesn't matter. Okay, cd build bin lib debug cv dump, and then let's do like common.pdb. Okay, let's put this to a file. And we're looking for anything to tiny GLTF. So you can see here that it is importing the GLTF as a directory. Let's look for some of these methods that it says it can't find. Like, I got so many files open. Let's kill some of these. Load ASCII from file, right? It is not included. But what about like something else that is obviously being loaded from this, like parse WLD? Yeah, you can see here the S3D loader is being included as a class in the functions right here, right? Same thing with like the Quake 3 loader. Q3 BSP. You can see here's the include folders, like the file paths, right? And then here you can see all the different imports, right? But GLTF literally has one entry, and that's the include path. So my files aren't being included properly. Let's rebuild one more time. Also, this needs to be on the Windows debug. All right, let's do this again. And so, I mean, it's accurate. There isn't proper includes going on here, obviously. But the question is why aren't these including? What am I missing to make these be considered include files? Are they compiled for non-Windows? No, I mean, there are some GNU and Android checks, but I don't see anything necessarily stopping Windows from including these, and it's not compile erroring. Interesting. Let's do, wonder if I make these considered like sources, like, just curious, what happens? Does it even change anything? No. Didn't think so, but I had to test. The library common puts it into lib. It should be in the common PDB. Interesting. Is it possibly having to do with the fact these settings are in again? Let's take those out. Not my cup of tea. I'm kind of stuck. Is there alternatives? Maybe I need to read some other... This seems to be the king. This is just a bunch of GLTF. I don't need... Header only tiny GLTF library. Do you think it's a version issue? I mean, I'm compiling with C++11. I wonder if this will impact me. It's telling me I need to define before including. Is that maybe part of the issue? Ta-da! Nice. Okay. Well, thank you. I will do a thank you. Okay, let's now do a new build. Okay, now we're going to go back to bin. We're going to run EQX, and we're going to target in the debug folder my box.gltf, if it's there. Mesh cube. Nice. So now we have a GLTF loader. So we got a lot of work to do, but I'm curious if I can convert the GLTF mesh over. Let's do a GLB to world as well. Should be as simple as this. And both of these are going to call some sort of mesh converter. In fact, we'll probably call it like GLTF mesh. Sure. All right, so did we make the GLB one? Yes. and it's not included though in the header. And then we also need file extension check here. That code right there is just about to get removed. It's getting more and more there. So I say mesh cube. All right, that'll fix the new line error there. I just want to clean that up, even though it's just a debug message. Come on. There we go. So, GLTF, success. GLB, success. I don't see the to-do, but that's because I haven't called it yet. So what we're going to have to do is probably pass the mesh, which is this. It is defined. It's a tiny, oh, it's capital M. Well, I'm getting all these errors now. What did I break? I broke something in this code. Interesting. Is it because I included it here? Okay, well, let's focus on the first errors. Those are gone. This now is unhappy with standard. Why aren't these giving me the line numbers, by the way? They're all in MSCV now. I wonder if it has to do with my include. I need to keep these defined in the header as well, probably. No. Well, crap. Let's just do this for now, I guess. It was not at all happy with mesh. So can I revert that fix, or am I still erroring? I'm still erroring. Okay, so what did I mess up? I added something, and it is very unhappy now. Name must be a namespace name. It is. It's tiny GLTF. What? I'm guessing there's some sort of cached copy problem. Isn't CMake have a clean rebuild? I might have to run that. That might help too. Nope. I still have some sort of error with including this namespace. What did I do? CMake lists common. Still has GLTF. Yeah, what files are changed right now? We added in 3 entries. They're currently not referencing GLTF. We added in this import. We added in the new converters. We did some tweaks to the BSP to world and the world to BSP. We added in the new GLB includes. Yeah. Oh. How did I remove this and when? Kind of need that. Well, we know these are fine. And this is just a minor correction. This should be okay, but I'm not going to commit it just yet. That's just commentary. That's just a new line. Okay, so what did I just break? Let's take these functions out temporarily, or at least neuter them, so they're stubs, because something is unhappy, and I'm not fully sure what. Does this build successfully? No. So there's some other issue going on. Let's take out all of this new code I added. And there's still an error. So what else is changed right now? Like, I've really moved a lot of things out, so this is not as much necessarily to test. Why is this committing? It's like identical. Interesting. All I'm doing is importing in the GLTF stuff. Is that what it's taking to hurt this? What's going on? Maybe I got to do a clean rebuild. If it's still erroring, we definitely know. Yeah, there's some sort of lingering problem going on here because I've stripped all of my GLTF stuff and it's still doing that error. So there must be like lingering data somewhere. No, it's still doing it. A namespace definition must appear either at file scope or immediately within another namespace definition. What are you talking about? What's going on here? The first changed file is this. All right, I'm going to keep taking stuff out and see if we can get this thing fully removed. Nope, still an error. Do I need to rebuild my CMake? Okay. We still get this error. What in the heck am I doing wrong? Did this file get edited or something? Is that maybe what's going on? The STL compiler preprocessor def. Is that maybe getting called because of my added header? Let's reload the window. This is so confusing. Did I maybe call a define and it's like lingering? It's kind of what the symptoms feel like. Yeah, see, you can already tell there's errors of namespace. Why? Yeah, none of these are going to be impacting what I'm working on. I am so confused. Fun times. Let's see if we have another route we could take, possibly. Maybe what I would like to actually do is I'm going to re-implement all of my junk. So like this is the GLTF loader. Oops. No, this is not. This is the GLTF loader. Right? Then this is the GLB loader. Right? Then we need to add extension support. And we need to add the headers back. What I'm going to basically do is I compile on my Linux box as well. And I want to see if this just goes away once we build on Linux, because there's some sort of lingering error that is just spamming the fuck out of me. And I don't really understand why. It's almost like compiler version got messed up or something. But nevertheless. Went ahead and compiled. Switching over to my laptop here. I'm got on my lap over here. I'm going to pull down the latest. Oh, I got some lingering issues on my local file. Okay, let's pull it down. And let's go ahead and rebuild. Let's see if the make file even generates, or if I'm going to crash. Error. Oh man, there's a lot of errors. Oof. Okay. Namespaces can only be defined in global scope. Is the error on the SDK. It does not like my libspace, libcpp include. Might even. Oh. I did not include the header stuff, did I? Where is that header stuff? It's basically this, though. Right? Which I know this is going to just crash. Standard works now, though. No. Let's add the missing header. Push that up. And let's see if this compiles for me here in a sec. Did you push? I think you did. Refresh. Pull down. Thank you. Let's rerun the compiler. Boom, immediate same errors. I'm gonna actually do a make clean. This thing compiles pretty quick anyways, but very weird. C++ can be super annoying sometimes. Like, some of these errors are just a pain in the ass to debug. Okay. So we have a lot of errors again. In fact, it's very similar to the errors we have on the other one, which is, in fact, I think it's the same one. Namespace can only be defined. No, it's slightly different, but it's kind of the same area. So what the hell is TinyGLB doing that's like jacking with? Very confused. If we go back to the source code, okay. We have TinyGLTF implementation STB image implementation, STB image write implementation, and I don't think we need the MSC disabled. Then we have an include to tiny GLTF. Then we're using the namespace. And yeah. When I hit make, it errors, and it's just like complaining about some really weird things, like namespaces can only be defined in a global or namespace scope. What? And this is erroring on my like SDK includes for C++. Another one, same error. Another one. It's all about namespaces. I think after that, all the other errors are just cascaded results of the first one. Let me see if I can find an error. What did I break? I'm going to jump actually a couple commits back and just see if I can figure out if it fixes my compiling. So like if we go back to here, can I pull this? I forget how to do this on here. Compare, copy, open, switched commit. And let's see if it just magically works, because this did compile perfectly fine before. Okay. It is. So this compile is good to go. Also, now that I've jumped to this, look, it loses. Like, where's my other commits? Can I see the commits from remote? There. Okay. So this commit, we added files. We put in this. We did a quick comment on that. We added in the GLTF stuff. And that's it, right? Okay, so let's jump to this commit. And do we compile? No. So there's something in this file that is just crashing the hell out of things. So let's take GLTF out of the picture maybe. Again. Including, this isn't included right now, so. Let's go ahead and take these functions out altogether for now. They're committed. We have a copy of it. We don't need them because we're trying to figure out what the hell I did. Okay. I thought I took all your function calls out. Oh, there it is. Hey, I hit delete. There we go. Build. Okay, success. Now let's add the functions back in. And just stub them. Whoa. Right? Interesting. So my errors are with my functions. What did I do with my functions that's wrong? Oh, snap. There's the issue. Okay, that was a pain in the ass to figure out, but now I got it. All right, so we're going to revert this shit. Let's switch to this latest commit again. All right, so we're latest, all right? We have all the shit imported. We should be all good to go, right? This is all I had to do. Man, those errors are so damn cryptic. Okay. So with that all done, let's go ahead and also put back in mesh. I actually don't know how to do the tiny GLTF namespace. I'm assuming it's all lowercase. Yeah. Done. Yay, it actually works, and I can actually pass the mesh over. Okay. Though honestly, I'll probably pass the entire model. That makes more sense. GLTF model to world. Like that. Right. Now we go back to you. What a pain in the ass. GTLF model to world. Okay. We are done. And let's test it working. To do GLTF mesh to world. Yeah, that's close enough. We've gotten it to a decent state now. Now, I know GLTF to world to GLTF is something Ali had actually already done. That was a lot of distractions. Let's go ahead and commit this before I even move any farther because oops. Why is my commit weird? That's a little concerning. I might have just committed that. Where the hell did that just go? Well, I can redo it, I guess. It's not hard. Just a little annoying. Like, where did I commit that? Is it in a branch somewhere? Apparently I have a branch. No, I lost it. Or it's somewhere. I must have had a detached head and it is Yeah, I only have one branch. Interesting. I must have not pushed it, but regardless. GLTF model to world. Model. Wait, why is model undefined? You should totally be defined. Did we? Yeah, we gotta fix this again. Untitled GTLF model. Include GLTF tiny and does it compile? No. Tiny GLTF. Oh, I have a single colon. I have that habit. I don't use namespaces double colon often enough to remember that offhand. Okay. Now if we go back to terminal, we get what we want. And we can go ahead and add this. Fix GLTF model loading. Sure. Now we're 100% committed and the latest, right? Fixed. Yeah. We're in the latest branch. There we go. Good. Good. We can clear this out before we get to the next step, which is to start working on getting the... Is this Ikema stuff or something else? Mostly Ikema stuff. I know you can hear me. Look at this. Restream isn't relaying chat. You slacker. It says it is, but it is not. Oh, connection expired. I gotta fix my session. Let me do that actually real quick. Come on. There we go. And can I please just get... There we go. Invalid username and password? That's not good. There. I'm going to do a re-auth. I'm pretty sure I can do this while you guys watch, because it's just going to do this. There's not going to be any codes. There we go. Yay! And now I can see your chat without tabbing over here. All right. So we have GLTF loading the model now. We have the model in here. The next step is let's look at Ali's changes. He has an S3D to OBJ converter here. This could be enough for me to do what I need, but I'm going to double check his GLTF one as well, which I think is called like Visual EQ. He has a GLTF exporter even. Perfect. It's in JavaScript, which is going to hurt my head, but all right, so convert zone to GLTF. All right. He is doing a type check. He takes the mesh, he loads it and adds it to the scene. The load mesh function is what I really care about right now. All right, so this is the reference that we're likely going to do. And it's going to need a cache and all this other junk. I may end up having to make a class to track this easier. But for the time being, I'll keep them functions. Short and simple. For now, we're here, and we have a model, and we're going to be putting it into WLD. So a unparser, whatever, will actually give us a lot of information about how the zone is going to be loaded. Okay. So at this point, he's already taken the skeleton entries out, which this is for, okay, we got polygon textures. I'm not fully sure what fragment is called polygon textures, but we do know that there's a type of mesh. Does mesh get handled in here, and where? Polygon text count. This looks like texture data. Then we have texture names. And we have a vertice thingy. Is geometry referenced anywhere else? 3 is using the geometry. Polygons. Is used in indices. And then he takes those indices, whatever, and then sets all the data. Okay. So there's a chance for GLTF to WLD, the fragment can just be literally created out of what's called polygons, which polygons is referenced at body cursor on mesh. See this? There's the count. Oops. There's a polygons push. Okay, so a mesh file has the polygons. Okay, that's what I wanted to know. Because now if we go to the S3D loader, probably geometry, you can see there's polygons in geometry. And then the geometry uses mesh, which I'm trying to remember where this is at. Some of this is not super clear. Mesh reference is in the fragment here, takes the frag buffer, turns it in to data, which is a world fragment type, and a mesh reference. Where is the actual mesh? Class. I may need to revamp some of these. Like world fragment is too big, and it's a little weird how it references everything. Because we want like mesh, right? All right, so here it is decoding mesh data, putting it into vertices and normals, color count, and then you got polys. Polys, there we go. Okay. So in theory, we can go back to EQX. We have model, And we need to make a fragment, specifically a mesh fragment, which is going to be like S3D fragment, I think. I forget how this is. It's like this. Arguably, we're making a mesh. Like, that's the real goal. Do we have a initializer? Is this just literally new mesh? Let's try. Is there any overloads? I mean, yeah, technically, if we wanted to turn it into a fragment, but can I just do this, or does it need a mesh reference? Yeah, it does. Because every time it's ever done meshes, it always wants a source world fragment. Yeah. See here? Arguably, what we could do is use set data, pass it a shared pointer of geometry, and we can cast this into let me see here. See, data in model, geometry can turn into a fragment. So arguably, we could use a model Yeah, where is the property for data? Data is built into this, and I think it's public, right? Yeah. Okay. So I don't technically need this. I mean, we could put this in the class later once we prototype, but what we need is model, which we're going to call mesh. Technically. Okay, so now mesh has stuff inside of it, right? I'm not fully sure how to work mesh, but it's called model here, and model is manipulated like for this: get polygons, get vertices. It's doing all these model operations, right? Model set name. This is how you do a new one. And this is likely ikiimu S3D geometry. All right. Now we're going to rename this to mesh. Honestly, we could call it geometry or something. Or how about this? World model. And of course, this geometry function or class. Okay, so vertexes and polygons are structs that are inside of it. And vert is a private function of a vector. So what we're likely going to need to do something like this. No instance overloaded function. Oh, we have to do a pointer. Right? No instance of overload function matches the argument list. Well, verts needs geometry vertex, which is what this is. Insert is it push? Maybe. What am I doing wrong here? That could be it. And we don't need it to be a pointer. It looks like maybe, maybe not. Yeah. And we're going to actually call this add vert and add polygon. There we go. So now that I have that, we now have add polygon and add vert. And we can start to do something similar to this. I don't know what polygon flag is, but we can add the vertices. And this is something that already is being done inside here. We create the model. We set its name based on the fragment name. So in our case, set name based on the models. I don't know if it has like a name. Let's just call it path. Okay, now we can add vertices, right? Or polygons, really. So we have animated vertices, vertex count, polygon count. So that means vertex is vertex X, Y, and Z. Vertex count, vertices is after texture or before texture. If we go back to world fragment, you can see here is the vertex being converted in from world to mesh. Here we're doing the opposite. So what we can likely do is do a for auto vert range over the model vertices. I don't know what they are in meshes. I don't think vertices are position, but I think that's a mesh. Yeah, what are our different types? We got meshes, nodes, lights, images, extras, extensions, buffers, accessories, animations, assets. It looks like a mesh thing. Didn't I get this to do XYZ earlier? And what did I do? I forget. This is getting confusing since I'm like using 3 different formats, but mesh yeah, I'm pretty sure I did this just a second ago. Did I not? might have not stored that actually though. Crap. I'll have to kind of do this blind. Wait. So we have mode, indices, oh, this is just an int. Okay, so we have attributes, extensions, extras, indices, material, mode, targets in the primitives. What else do we have in here that's interesting? We have a mesh name. We have a mesh weights. Wait, was that in the list? Yeah, it's a double. These are the different weights of the mesh, which we probably won't ever use. I'll leave it in there just for reference. Mesh extensions. So it's a string and a value. This might be the property system. Extras is just a value. What else we got in here? Name is per mesh. I think those get ignored. Then we have primitives, which we already started, and we have weights, which you already did. Is that all of them? Yeah. Extras. It's just a value. Okay. So in primitives, we have attributes. We have extensions. We have extras. We have indices, materials, mode, targets. What is the key value system of, how do you iterate a map in C++? I forget. Whoa. Yeah, that's one way. So this would be a string. And then there'd be an int. Okay, what else we got? It's only targets, okay. So So this isn't really XY coordinate data though, but you know, we're moving along. We could actually open up the GLTF and probably get a hint of what exactly we're looking for. So let's do that. Let's go to bin debug and find the GLTF. We'll ignore scenes. We have nodes, which is actually super helpful because we actually learn lighting data by nodes. So let's make sure we also get nodes. Whoa, I'm not looking at all this data. So for auto mesh model nodes, let's try to add in light data real quick. That should be a little easier. So right now we have a light positioned. Let's figure out how we answer. So in nodes, the name is important. Is this literally what this is called? It looks like it. But there's translation data in a light. I'll probably just use the word light on. Is this a string or a... I'm assuming it's a standard string. Let's see. Yes. And I think compare, if I put in the word light, is there an I compare? I forget. My string manipulation code is not the best in C++. You have position. Honestly, what we should just do is find the word light. Is there a string find case insensitive? Ooh. You have to iterate and do an upper. Eesh. I mean, I can just throw this in here. This would be I find, in my opinion. Does this compile fine? No. Why am I not compiling fine? Identifier not found. It's because I did not include it in my header. There you go. There we go. Much happier. Now, let's go ahead and figure out the next one. We have a node. We know that it's a light.
we have translation, which is the XYZ coordinate data. I'm guessing it's just translation 0, 1, and 2 every time. So we don't know how to make world lights yet. I know it's a fragment. I'm pretty sure light data is its own project, but we'll just do this for now. Will that work fine? We can test. Yep, 4.8 is pretty much that one. Yep, rounded. So we're going to say whoa, I did not press that. Okay. What this should do is give me a light coordinate. Yep, XYZ. And it matches 4, 5, 1.0, and the name is light. Nice. We don't care about camera. Materials we are going to care about, but not yet. So then we have meshes. Now in meshes, see, this is so much easier when you can actually see the project. Because you can see here, a primitive references a indice, and that indice, I'm assuming, is described here. Position, normal, text chord, material, and indices. Then we have material data. So mesh is referenced in nodes. And that's how you get a mesh name. Well, the mesh is also referenced here. So for now, let's do a printf. And this will be the mesh name. Okay. Why does position say 0? Or is that because it's an attribute? Where's the attribute stored? Let's move its location just a little bit. Like 1, 2, 3. Save. Export as GLTF. So I just stored the number 1, 2, 3 for its location. There we go. When the translation is empty, it just puts 0. So I'm glad I moved it. Okay, so we know that there is a cube positioned in this mesh, and it's actually during nodes that we find its location. Interesting. 4, 5, 6. Nice. So nodes is where a lot of the interesting data is actually stored. So a light is actually just an object. What turns it into an actual light? At least, you know, for Maya and Blender and such. Is it just the name? Let's like try to increase the data of a light, for example. Object data properties, which, you know, this is a point light. Let's give it like an RGB hue of like 1, 2, 3. No. 1, 5, 2, 5. So we get a nice pink, all right? Let's also call it light test. So our light is still considered light here. Where does the name light test go? It never actually exports the word light test, does it? Interesting. Is it also because I did not really call it light test? I called the object properties light test. Let's do something like that. Is light info searchable? It is not. So the light data is gone. We don't have this being exported. That's annoying. But that's not end of the world. We can make that work. So light test has a rotation and a translation. For now, we're going to skip lights. And instead, we're going to look for same thing if it's a camera, we don't care. Okay, so now that we've excluded these two entries, we're going into the cube world. So we have a cube, and we know that it has a translation. Which I think is just literally, yeah, this is exactly like what we did over here. Like so. And this will give us the translation data for XYZ. Printf is wrong. Why is printf wrong? Oh, no semicolon on the end. Did I not finish building? Printf, warning. Oh. What's crashing? STL verify. What's my stack? This conversion is taking cube Okay. So what is this doing? It's taking cube and we're finding 3 elements. Oh, this cube data does not have translation. So we have to do a size check. If node that'll fix the error. That makes sense. And that's because the cube mesh data does not include any data about positioning, which is interesting, by the way. Ugh. Okay. So, what else do we need to work on? We have loaded in some geometry data. How does this become a cube? I'm guessing this data is impacting scale and such. 4, 5, and 6 was used during scale. Okay. So my question is how do we get vertices out of these coordinates that I just got? Because that part is a step I'm still working on. Because you notice we have translation data, light test. We don't ever get light info, do we? We do have some buffers and accessors, which I'm not sure where these are referenced. Buffer view is buffer 0, and the length of each buffer is set in this. I see. So when you're navigating a node and you hit a mesh, what you're supposed to do is if model meshes.size is less than, and then we're going to have a node mesh. There. And then a mesh has primitive data, like the material and whatnot stored there. Got it. These indices. Wow, there's like commentary. That's amazing. Like, good job, GLTF. So for example, to get materials, we have material, right? And then we basically go if model materials size is less than prim material, we can do a similar warning message and just be like node s refers to mesh Why is my EQ log message wrong? Oh. Okay, what else? Yeah, it does. Doesn't have materials. Oh, not node, model. Okay, and then we can now say auto material, well, prim, no, model materials, and then prim material, and this will give us the material data. And we're going to have to figure out how we're going to do all this, but we now can reference material data. We'll just use name for now. Mesh material. Okay, so node the mesh number, the material number, there, and then the name. Okay, why is the cube node not maybe didn't compile just yet? And why is this erroring? So 1, 2. Oh. Maybe? But variadic argument has type 3. There. There we go. So now we reference the material name. Cool. What else we got going on here? Why is Twitch messaging me? Oh, somebody's saying hi. Cool. We don't need this anymore. The next step is we need to turn a... How do we get the vertices? The min and max values provided an outer bound box for all the position data within a given accessor. Accessors typically contain multiple vertices. For example, all the vertices of a particular primitive, and then min x, min y will offer the bounding box for that primitive. Mode 4 is an enum, where 4 means triangles. Triangles are stored in accessor 0. Oh, okay. So we're in the primitives. We got the material done. I don't get you sometimes. Like, why are you auto formatting my code? Like, this does not go on the same line. What the fuck? You did it twice. Okay. Now that we have those, we are going to see the mode of prim. Interestingly though, 4 is not defined. Primitive, attributes, mode. I'm assuming, what's the default mode? Can you just give me... All right. Default is 4. Zero is points, 1 is lines, 2 is a line loop, 3 is line strip. Set sow wow. Well, right now you're just looking at code. I'm basically working on a EverQuest S3D/EQG WLD parser that can generate zone files and stuff for us. It's based on similar stuff that already exists, but yeah, line loop, line strip, triangles, triangle strip. Right now it's pretty boring stuff. I'm just coding triangle fan to make your own zones, basically, and own NPCs. Like, for example, I'll show you real quick, as a quick distraction. We're going to start up a EverQuest client that I'm modified pretty heavily and did some random ass stuff too. And what you're going to see is when I enter into my Demancia server, which will take just a moment to load. Boom. I have custom NPC models, and a background you'll notice is a custom zone as well. You got gremlin goblin person and a hook horror and a little Cthulhu dude. And yeah, I have a couple different zones I'm working on. Technically I'm up to 3. You'll also notice, so like this is a different zone too. You'll notice I am a kobold and I am in Delves, which is a new zone that you've probably never heard of because I wrote it. It's called Demonic Delves. You have entered Demonic Delves. And this is basically a big boss room. The idea being you can, oh, is it 40? There it is, 49. This is just a room where there's nowhere to hide from the blasts of a boss, right? It's just a big circular room. And then there's a boss in the center. So I made this zone. It's a really simple zone, but, we could also go to Hollows, which is my survival zone. Coordinate data is not... Oops, I'm dying. I fell over. I apparently was not in GM mode. And I can't heal myself because I can't target. Interesting. Will I regen eventually? Am I dead? Interesting. That's an interesting bug for sure. Let's zone back to CLZ, which will be interesting since I'm still laying down dead, technically. Oh, okay, it fixed me, even though my camera got jacked up. Ish. All right, there we go. And actually, we're back in Hollows. Interesting. I guess trying to zone for CLZ when I'm still in here on Death's Diet, we get zoned back. But anyways, the idea behind this zone is that I'll put an NPC here that you have to defend. And man, this is really dark. Oh, well, whatever. There's going to be these little corridors that mobs are going to come from. They're just dead-end mob zones right now. They're all going to run for this mob, right? And you as your group, there's like 4 of them, 4 little pathways. let me relog real quick as Shin. Oh, zone is unavailable. I didn't spin up a lot of zone files. Let me do that real quick. As far as your question, so it's used for custom EQ client servers? Kind of, yeah. I mean, the general goal in the long run is I want this to work also for servers that just want to modify the original files, the zones, and like clean them up. There, added more zones. For example, P99 has a few issues with bad geometry data and stuff. So, all right, let's go back to hollows real quick. And I'm going to die. Fly mode 1, go to 0010. All right. Anyways, now you can actually see a little bit better. It's still dark, but you can see here, though, that there's like the Sol Dungeon, graphics, or it's really like a Neriac zone, right? I got a little bit of dynamic lighting going on in this little, kind of modeled after some of the stuff you'd see in Neriac. Intentionally, like, way too big textures and stuff, because, I'm trying to keep a P99 feel, or, classic EQ feel. And anyways, yeah, there's these, I still have some tearing going on the bottom there, but there's these little corridors, 4 of them. Mobs will just spawn and run in, and it's just like a little ring event, if you're familiar with that from Shadows of Lucklin. That's kind of what the plan is. Figured it'd be kind of a quick and easy little zone to test with, and yeah. So that's kind of where I'm at with zones so far. All three zones that you saw, I wrote from scratch, which is kind of cool. And the tooling that currently exists for EQ is kind of lackluster, unfortunately. So I'm trying to improve it. And to do that, I have to create a baseline. So that's why I'm coding right now, is I'm working on a project of converting GLTF files into zone files or BSP. I'm kind of hoping to do both eventually, but whatever one's the easiest is my goal, because I don't care where I work on it. So where I'm at right now with this tool is I have a few operations I can do. For example, I don't know how familiar you are with development with EQ and stuff, but S3D files are basically zips that EverQuest uses, and I'm taking the S3Ds, and when you target it with my tool, it extracts it all into a subfolder with a underscore prefix of the same file name, and then just extracts all the data, right? 1-to-1. Simple enough. If you run the tool and target the folder, it will repack this back into the S3D. And I'm doing this just so that it's super easy to go back and forth between, uncompressed and compressed versions. And that's because my next step is, for example, the WLD file. That is the zone data file, right? Like, that's actually what contains a good chunk of the geometry. And what I'm trying to do is create a bidirectional conversion so that WLD can turn into like GLTF or, OBJ, probably just GLTF, because it's modern, it's simpler, it has all the data we need. And that'll convert zone files back and forth, is the hope. Then I'll take a lot of this other asset data and basically start writing conversions so that you can take raw files, pack them into an S3D, and get them back into the S3D super elegantly. Because right now, every time you do that, you have to use tools like EQ Zip, which is very tedious because it's GUI. So every time you open it, you have to go find the directory, find the file, go to extract or save. It's just very tedious and honestly just not well thought, in my opinion. So yeah, I'm trying to streamline importing, exporting S3D files. It does. There are some like non S3D/EKG support in the client, but it's not very good. It's very limited. Like you'll notice there's functions that literally just load MPC data from the S3D, and it's calling the S3D specifically. And the paths are fixed. So yeah, unfortunately. But yeah, so for right now, what I'm doing is I'm learning GLTF data because GLTF is a great format to import from because it supports custom data points and all that fun stuff. So if I write a manual, I can sit down and teach people, how to create a zone, even with all the custom unique EQ zone stuff inside of it. And I'll probably do the same with NetRadiant as well, if I can, which is what I currently use to make a lot of these zones. Like here's that Delves zone. And this just gets generated as a BSP, and then that BSP gets imported in through OpenZone. This process, though, has some headaches, and I may be able to bypass it. I honestly don't care, but whichever one ends up being the easiest to convert is my goal. So yeah, for now, I'm learning, like I said, the prim mode, and I'm just documenting each type, which goes up to 6. I think I finished number 6, right? Which is triangle fan. And what we're going to actually just do is do a quick check to see if prim mode does not equal 4. Let's send a message out that just basically says node X refers to mesh, blah, and stores data as mode boom, which we don't support. I like informative errors because when I hit them later, I don't have to guess as much on what the heck's going on. So there you go. Prim mode is added. So if it's also, I'm curious if that's actually going to get triggered. Let's build it real quick. I'm guessing you're a programmer by trade. It seems a little daunting to get into for us folks. Yeah, this is definitely high level developer stuff. I am a programmer by trade. Yeah, and you can see that the mode is set to 4 because it succeeded. Nice. Cool. So now that we know that prim mode is set to 4, we can safely go for the indice, which we found out the indices accessor tells us more about that. Which we can see here, accessors. Okay. So, accessors is its own section. So let's go ahead and see if we can actually access it. Model, accessors. So, first let's do a sanity check, which is if model accessors size is less than prim indices, then we need to error out that to mesh accessor or indice, which is larger than accessors. There. And then we go to prim indices. And now we have this data. which I believe correlates with this data right here. So now we have a min-max vector with a count of 24 inside the buffer view of 0. So buffer view of 0 is this, and count, not fully sure how that works. So I guess we can keep reading the documentation. This documentation is actually really good. So we now have accessors. A buffer represents a block of raw binary data without an inherent structure or meaning. This data is referred to by a buffer using its URI. The URI may be either its point and external file. Let's see what the minimum version is. This is just a quick example, probably just a cube, or even more, it's a triangle. And you'll notice that it still has a base 64 string in the buffers. I'm curious what this gives us. So you can see it has a reference to buffer view. And if I go to buffer, does model? Yeah, buffer views. All right, so let's do another quick sanity check and see if buffer views has so we're going to reference the accessor, right? Just to simplify our life here. And we're going to say is accessor buffer view too big. So this refers to mesh X. And then mesh X refers to indice blah, which is larger than buffer views. Okay, so after indices, we need to add in accessor, or no, we need to add in, yeah, that. Okay. So now we know the buffer view exists. We've sanity checked it. And now that we have the buffer view, let's go ahead and access its data. Which is going to be buffer views, prim indice, or accessor buffer view. Okay, now we actually get the buffer data, which, this is interesting. Let's see. We have a byte length offset, byte stride, Dirac decoded. What is Dirac decoded? It's a Boolean. Extensions in the buffer and extras. Understood to be tightly packed attributes. Could be 0 for other data. None of this else has commentary. So let's revert back to here. Okay, parts of the data of a buffer may be passed to the renderer as vertex attributes or as indices, or the data may contain skinning information or animation keyframes. So it's just a generic blob. In order to be able to use this data, additional information about the structure and type of this data is required. And that's where buffer views comes in. The first step of structuring the data from a buffer is with the buffer view object. Buffer view represents a slice of the data of one buffer. This slice is defined by using an offset and a length in bytes, the minimum GTL of two buffer objects. I see. So 0 through 6 is this data for the target, and then 8 through 36 is the other chunk. Yeah, visualizing it there. The bytes that are shown in light gray are padding bytes that are required for properly aligning the accessors as described below. Yeah. So, yeah, it's just 0, 0. It's interesting they're using an int16 though instead of a int8, but whatever. I'm assuming buffer is going to actually contain the first 288 bytes. I'm going to breakpoint, build, and then let's take a look at this buffer. I'm curious if it has 288 bytes and they've already split it for me. I'm assuming they did because this seems like a pretty slick little program. All right, so we're breakpointed. We have a buffer, which is negatives. That's interesting. Why is it negative? How about buffer view dot buffer? This is an int? Oh, we may be jumping a gun here somewhere. Yeah, buffer is just the 0. I think I have to take the data myself. That's annoying. I mean, I can do this, but right. Let's keep reading while I consider what's next. The type of the accessor's data is encoded in the type and the component type properties. You're right. So when we're in the accessor section, we're going to make sure that component type, the type of components, it's the, okay. So we go back up here, you can see type of pretty much all of these is vector3. Scalar, is this a string? No, that's component type. We want type. What are the type integer stuff? So accessor type. Mesh primitive. What about buffer? View schema type. vec3 is not in here. Let's search for vec3 in schema. There. No, that's an example file. I need the vec3 to be defined. That's a GLTF. There's the README. Wait. Okay, something is odd because I can't find the enum of all the different types. And it's probably because it's a string. But why is this one of the tiny GLTF types? Oh. So what we can do is find, there we go. This is what I want. So if accessor type does not equal tiny GLTF type vec3 Yeah. Well, then node blah refers to mesh blah in the buffer views, right? No. Buffer views is still being used at this point, right? No. Something like that. So the error will tell us that it's an unsupported vector type. Does that compile fine? And this should error every time because I don't have... Maybe not. It's because the buffers are only... You know what's actually happening, I think, is that attributes is the index of the accessor containing attributes data. 0, 1, 2. What is 3 for? Is that referred to anywhere? I don't see it, but maybe what's happening is 0, 1, 2 attributes are referencing 0, 1, and 2. So what we need to do is, as we get the primitive data, we need to iterate the attributes. They're actually an array. So at this point, we have prim attributes, which is a key value pairing. All right, so we're going to have to do something similar to my ITR, which I wrote earlier, and it looks like I removed because I don't see it. Because I don't normally do begin stuff. All right. So we have to iterate the attributes. Right about here. So for auto, this is going to be like KV. I'm not going to do this off my memory very well. There it is. so this equals the beginning of prim attributes. Okay. Now we iterate until kv is not equal to prim itr end, and every time we hit this, we increment by 1. All right. Now kv first is going to be its name. Can I switch on the string? I think with C++ it doesn't like this. Yeah, see, it's not happy because const char. Maybe with a C string. All right. Expression must have an integral or enum type, or integral. Wait. Is it first? Yeah, it's just first. Script if first equals position. Still not happy. Oh, it is. Okay. Yeah, switches are like really explicit on what they'll work with. That's fine though. Now this is going to be the index. So now that we know that it's a position that we're about to grab, I'm going to have to write a tool to convert all this, but we got a position. We're now going to go ahead and take the second value, which will be an integer, and access it with this. Why does it say, oh. Okay, so now we have this accessor. All right, so now we have the position data being loaded. I'm going to build this again. It does not say got position. Interesting. Why not? Okay, so cube node, this code runs. Cube node mesh 0. Material. I'm apparently running different code. We're hitting here. Yeah. Okay, so node Q refers to mesh indices buffer views type 3, which is not what it is. Wait, why would this is actually let's verify that this is the right line it's triggering and also that it is doing what I think it is. Okay. Attribute position, buffer view 0 type 3, which is not vec type 3. They totally are. 3 equals 3. Let's just put 3 here, or better yet, int convert this. Maybe that's the issue. Node cube refers to mesh 0, indices 3. Attribute indices can actually be removed from this. Attribute position, buffer views 0. What buffer view actually hasn't been accessed yet? Type 3. Yeah, this is wrong. Second is convertible. But why is 3 not equal 3? For the time being, I'm going to take this check out. And we can continue. Ugh. Okay, so we now have access to the buffer view, which is going to be 0. What do we do with this? And is this normal to have to do all this effort to load something? I'm actually curious now. If I go back to tiny GLTF, if it has a So it loads the binary, creates a model, it iterates the scenes and the nodes, it gets the node, it uses parse node, so here's a matrix that it's making. Here's your vertices. So it's taking the primitives. Look at all those nested conditionals. All right, indices. Buffer views. Buffer. Then it does a byte stride check, and then it takes the component type. And I'm gonna have to probably start this later, but yeah, you can see here, if GLTF buffer type equals position, so we're getting similar code. Yeah, here's first GLTF type. It does a check with the component type. Is that what I'm doing wrong? No, that's type. But regardless, then it converts the position, gives the vertice data. Yeah, I need to definitely bookmark this and work on this later because I'm running out of time. But no, I learned a lot. I got quite a bit ahead, and I'm actually getting closer to a good status point. I'm going to leave it like this. I'll commit later. Anywho, if you've been watching, I hope you enjoy it. I know it was pretty technical.